14th, and this is the libhal bi-weekly meeting. All right, for our agenda this week, we'll be going over splitting up libhal. This is going to be pretty interesting. So, yeah, code coverage. We finally added code coverage in there. It's big. We upgraded the CLI. CI, meant to say. There's a lot of little changes here and there. It should actually simplify the whole process when it comes to using CIs for different repos. Although I'm starting to realize that we really do want to have how should I put this? A more a standard for how libraries are put together, and I'll talk about that in a little bit. Non-demo libhal project boards. I'll talk about those. You'll see those in a bit. Updated instructions on setting up Conan. This will help people who may have hit some particular issues when they start to set up Conan. Libhal Starter, which is another project for helping people get started with libhal. It's still in progress though. Libhal landing page, just a little something to show off. And then also another thing to show off, which is the NXP Prog progress bar. I think it looks nice, and I want to kind of just show off some really cool terminal-based shenanigans and UI. It's some of the most beautiful things I've seen in a while. So, all right, let's get started. So, splitting up libhal. So, the libhal repo has become overloaded just in general. If you look at it, it pretty much has a whole bunch of soft drivers, testing code, and utilities. And now we're going to split those up, and we're going to now have libhal, which is just the interfaces and supporting types. Libhal mock, which is testing and simulation libraries, including mocks and supporting any supporting libraries. Libhal util, which is non-interface implementing utility functions. What that just means is that you won't find something that acts like an ADC in util, but you may see functions that make using ADC easier. And then libhal soft are the soft drivers that implement interfaces. So that's the distinction between util and soft. So you may see a bitbang SPI or a bitbang UART in soft driver, but you won't see that in util. But you may see I would say helper functions for using ADC in a special way. Like maybe it does 10 samples and it averages or something like that, given a certain amount of time or something like that. So why did this all happen? Well, when I was working on the architecture MD file for libhal, I realized how complex it was getting. I did not like how I had to describe libhal and how it was kind of organized. So I felt that there needed to be a bit of a change there. But I also sought a bigger rationale, because I know I could just kind of separate them out into different pieces just for organizational reasons, but I felt that wasn't a strong enough reason to do that. So I started thinking about are there any other particular things that I've noticed that have annoyed me, that have been feeling wrong? Because I couldn't, just because it felt a little off to have everything in that one repo, or the way that the architecture was coming together didn't seem right. I knew that there was something deeper there from my annoyances, and as I kind of did a little soul searching, kind of thought about it a bit, I realized that the main issue really had to do with semantic versioning and also how often the libhal repo changed. I realized that I disliked how often the version number for libhal ticked up. Specifically, whenever I made a breaking change to a utility. Let's give an example. Let's say I used to have a write function for writing a character array directly over to UART. Actually, literally, we just had something like that, something akin to this. And I realized that was a mistake, because when you do a write operation with a character pointer, especially if you use C++, I forget what you call it, but it's this type of C-style type template thing where it'll be able to deduce what the size of that array is. If you iterate through the entire array, you will hit a null character. You'll print that out. Now, when I was doing work with the ESP and doing stuff over serial, I was getting the null character spat out as well, and that caused a whole variety of errors everywhere. I think I spent a day actually, held back by that. And I had to then delete that particular, I deleted that particular API because I felt that it was actually the wrong type of API. We shouldn't allow it, and since we're early enough, it seems like a decent idea. Then I thought about this. In the future, where we no longer can just delete things willy-nilly, doing an API break like that's actually a bit of an issue, we now have some sort of technical, or not even say technical debt, we have a we have one of those edge cases that you need to be aware of. Like, oh, don't use this particular thing because it has these particular issues. I would love to be able to just simply uptick the major number for the semantic version. And if you don't know semantic versions, let me just bring that up real quick. Semantic versions. It's this site here. Major numbers when you have an incompatibility API change. Minor numbers when you add some functionality but you're still backwards compatible. And then a patch is something that keeps compatibility but just fixes a bug. So API does not change. Okay. I bring that up because I realized that a small change to this API that maybe no one's even using would make the entire libhal interface library uptick a major number, which makes it seem as if libhal, like the actual interfaces, have been updated and changed in some way that's breaking between one and the other, but your code probably wouldn't break almost at all with that change. That's all to say that I realized that I wanted libhal to become more stable. I wanted to only uptick on major or even minor or even patch only when something from the interfaces has changed, something that it changes the foundation of everything else we're building. Same thing with, and then when it comes to util, you can change it as much as you like, but we're still going to probably be, allergic to the idea of upticking major because that's going to be a major change. We don't want to do that. But separating them out means that we can make those bigger changes to util or soft or mock and not also, completely uplift the foundation that is libhal. Because once we start putting this stuff out onto Conan and other package managers, our version numbering is going to need to be very important that we keep that straight, and we are very conscious about when we uptick a number, when we uptick a number. So yeah, that's the reason why we're splitting up libhal. It really comes down to not just organization, which kind of makes things a little cleaner, having things separated into their own places, but also, I would say more importantly, when it comes down to versioning going forward. So me and Milo are actually working on this, and we're still doing a lot of work to make sure that we got everything all settled. Libhal soft does not exist yet. The conclusion to split up these soft libraries out of util came a couple days ago after talking about this divide here and semantic version changes between util and soft and how those would be categorically different from each other. So that's pretty much splitting up the libhal. So just keep that in mind. If you want to work on utilities going forward, you're going to be working in this repo. If you want to work on soft drivers, you're working in this repo. If you're working on mock stuff, you're working on this repo, so on and so forth. Code coverage. Really excited about this. Actually, I'm actually super duper jazzed about having this working. So, couple of things. First, let's take a look. You can actually see the little code coverage badge right here. Now we have it. Click on this. You can see it. It's right there. Boom. Beautiful. Absolutely love it. Well, if we click on it, we'll get to that other page that we saw there. From libhal get.io, libhal/coverage. Just like how we have /API for the APIs, we now have coverage for coverage. So every library, if you just put /coverage at the end of its URL, given that you're using like their GitHub Pages URL, not like their repo URL. If you do this, you should be able to get their coverage. So as you can see here, we have 100% coverage on this. Didn't take too long. All these are just interfaces, so writing tests for this was pretty simple. One thing I am thinking about, though, is whether or not to include the test files as well as the also source files. One of the reasons why I included the test files, at least for now, is because it is helpful to know if you didn't hit certain areas inside your unit test versus not including it. But the one thing about having your tests be inside of your coverage is that it's likely that you would have hit most areas of your test, meaning that if the number of source lines and test lines, which is almost never the same, actually, take that back. Let me rephrase that actually. You almost always have more test lines than you do actual source code lines. So because of that, your coverage is going to be artificially greater than it really should be. And that's one of the things I'm concerned about. But luckily, making that change should be relatively easy. So if in the future we realize we don't like having unit tests embedded in here, we can separate that out. If we really want to be extra about it, we could potentially even have a coverage just for tests themselves to make sure that your tests are actually like like we have a coverage one, and we have a coverage with tests coverage option, so you can see the two just for diagnostic purposes. One other thing to note about some of the changes here is that if we go over here to tests, you'll see that if you've ever done any unit tests with libhal, before the main test file was pretty much empty. You just have like a main and that's it. And all you had that main there for was to satisfy the GCC compiler, or actually this compiler in general. The reason why is because all the previous code used to, hold on a sec. All the previous code used to use this thing called suites. If I actually go back here and then go to ADC and then go to history, we can move back. Oh, this is before it was renamed. Yeah, let's browse that history. Let's just go here, add unit test free interface. We can see here that we have this boost UT suite. Now, this creates a object, a global object, and the global object's constructor gets executed before main gets executed. All global, if you didn't know this, your global variables inside of almost every programming language, but like in C and C++, and specifically, you have this set up before your actual code runs, before main runs, and that's where all your global initializers, all of your global data stuff, that's when they all get initialized. However they're going to get initialized. It depends on what you're doing and how you're setting things up. So this is part of the static global initializers. So it runs through all of our suites in whatever order the compiler decided to put them in, and then main gets called. And because our main was empty before, main gets called and immediately returns because all the work for the tests have already been done. The problem with this is that from what I can gather, I didn't dig too deep into the actual disassembly and like looking at how adding in coverage flags instruments your code, didn't care to. All I noticed is that our coverage was 0% the entire time. Anytime I did it this way. Then I realized that if I simply called one of, changed ADC from a suite to just a function, and then put all my tests in there, which should work exactly the same, and then called it in main, my coverage looked appropriate. It wasn't 100%. It actually had to fix it up because I realized that I was missing some stuff. But I noticed that that would fix it. So because we need, I think the coverage stuff for gcoverager or gcov happens after main gets called, or basically instruments before all your code gets called. You have to have it be called in main. So that's all to say that there's some changes that need to happen. Simply put, you have an extern void function, and then you call all your extern void. You call all your void functions here, and then any one of these can throw if a error occurs, something like that, or an assertion comes back invalid. And then a little static check to make sure this is running as a unit test. So going forward, if you want to register a actual test, you'll need to do a couple things. One, you just create a void function, put it in its own file. You can put it in the main file if you want, but I think having them have their own files makes sense because they get pretty long. I used to have a header file for this specifically. I actually removed it in place of using extern. I do this just because I feel like it's more likely for you to get a compile time error or linking error this way. Also, you get to eliminate one of the header files, so I eliminated that. So we just have your main and your other source file. You put an extern for the name of the test that you're going to be running inside the namespace. That makes sense. And then you just call all of them. And that's pretty much about it. But yeah, so that's the new scheme. This having everything inside of main means that you can actually get coverage. So that's that. We now have code coverage. I can also show you, the only other thing we've gotten set up for this would be ARM Cortex. And actually if I do what I have here, so we have coverage here. If I just change the thing in here to ARM Cortex, you can see that we get our coverage for ARM Cortex. And you can see very clearly that interrupt is missing a very little small sliver of some line. Yeah, this particular function is not getting called because you don't need to. It doesn't do anything. And then you have systic timer, which has quite a few lines that are not caught. Specifically, this source of processor, the clock being set to processor versus something else, as well as also a whole bunch of other things. So this allows us to be able to see where we're missing actual unit tests in our code. So really useful. So that is code coverage. Oh yeah.
What's the tool that you used for the actual report page?
Oh, for generating that thing, G Coverager. It actually says at the bottom. G Cov R. I call it G Coverager, but I don't know how it's actually pronounced. But yeah, I use that tool. Um,
Oh, okay.
yeah, you just
And then
set.
it's just like a page that's in your source code or your code repo, and then
Mm-hmm.
you just it like links to it.
Yep, pretty much.
Oh, okay.
Yeah. This
Cool.
is just a folder that has an index, a coverage, an index.html file, and then a whole bunch of other things like that. This software is, I would say, not the hardest to get to work, but it can be kind of tricky. And I did bring in some source code that had some kind of funky markers inside of it. Actually, I can talk about this now. So, side note, and I'm going to talk about this more probably when we get to the end, but Boost Leaf is still a dependency of libhal, but it's no longer a dependency via Conan, and that's because we started some stuff on Conan this last weekend because we added it in, and people were like, "Yo, you can't do this," and then big old back and forth. But I then took the single file header, embedded it directly into our software, and I was getting one particular issue where the single file header had this really cool thing where it manipulates the line numbers and it manipulates what it considers to be the start and end of a particular file. This allows you to get errors that follow your directory scheme before you minify the thing into one single file. Makes getting debug errors a lot nicer. The problem is that gcoverager was looking for files that don't exist on the system, and what it would do is it would crawl upwards the entire directory tree up until it hit root or somewhere where it didn't have permission, and then it would throw an exception when it didn't have a permission. And every single layer, it would spam a crap ton of files everywhere on all the files. Luckily, you can easily grep, asterisks remove them, but it's just a very big annoyance. So for the most part, this thing may generate some really odd files for you if you do something weird, but for the most part, it works pretty easily. If you want more details, you can look at the CI and how it's set up to see how it's done here.
Will this be a part of the starter template CI or no?
Not yet. I'm thinking about how exactly to include it. It shouldn't be too hard to do so. So a lot of the stuff is built for libraries specifically. I'm still considering how I want to do starter apps as well. They actually will probably look a lot like libraries, and I might just be able to just use the same exact infrastructure from what we have here for doing library stuff with actual tests. The only what was I gonna? Yeah, that could work. Because I think as long as you have a docs folder and the only difference is that like linting gets a little wonky because linting looks for an includes directory, whereas a project will have like a project folder or a source folder or something like that. But tests will still be there. So I can either have a condition to check for that. Basically, I'm still trying to figure out how to architect this. But I would love to have projects that are situated the right way or structured the right way to be able to just use one of our libraries and then get code coverage, get um, uh, pre-submit checks, continuous integration before you submit things, all that kind of stuff already rolled in. So it's on my mind. I'm still thinking about exactly how we want to structure that. It might just be simply, your source folder just be called project. But if you have any particular ideas about how you'd like it structured, I'm going to show you libstarter later on so you can kind of get an idea. But if you have like any oh, I don't like how you did this, or I think it should be better if you place it this way, or I think you should rename this folder to this, feel free to bring it up because any input or advice that I can get to make this thing better for users is always paramount. Any other questions or comments?
No, sounds good.
Cool. All right. So I think that was it for coverage. Yeah, and I explained how the code had to be refactored to get to this result. Yeah, I don't know if I have a spot for talking about the Conan stuff. Maybe I'll do that afterwards in this meeting, but outside of the recording. So anyone who's watching this from YouTube, you're just probably not going to get that little information. All right. So upgraded CI. So the CI for libhal has been condensed down to a single checks YAML file, which I will show you now. So the checks file does a lot of stuff. It runs your lint, it runs your docs, it runs the tests. You have a way to you have a input field where you can actually enable or disable coverage. The reason why you'd ever want to disable coverage is if you don't have actual unit tests, um, just in general. So that just kind of blocks that part. But you'll also like fail the test thing anyway. So kind of have it there. Depends on what you're doing. But I did add that in there in the event that like there was a situation where you needed to. So the new structure here is that the last one, they're all separate and you have to include each one and you just kind of include which ones you need. So that's way that you can get away with not having tests. But now that we're gonna have like libhal starter and also libhal basis, um, you should already have all the infrastructure ready so that even if you didn't add any code, all these things should just succeed. Um, So there's no reason why to exclude having unit tests as being part of the pre-submit check. And if you don't have any tests, I mean, and you're still early in the library development, just let it fail. Like let it be failed, push it through anyway, and then keep working on until eventually you fix up your CI. Nothing wrong with that until you actually publish the project. One new thing about this whole system is that like if you actually look at the action here, I kind of wish I could delete these or get rid of like these sidebars because I don't need them anymore and they're kind of confusing. If I go over here to revert memo, you can see that like the CI has some connections. So we have our different checks, and they all like our deploy and as well as our published artifacts are basically blocked on these guys finishing. Once these all finish, that's when we know okay, we're good to deploy. Excuse me, sorry about that. We're good to deploy, and we're also good to publish our artifacts to our GitHub pages, which you can actually see down here. So now the cool thing about this is that it's kind of hierarchical, meaning that like if Lint ever wants to push information to like GitHub pages to make that available, like information about some sort of Lint based analysis, then we could push that over to GitHub pages by simply uploading an archive or an artifact, I meant to say. So in this case, Docs uploads an artifact for the API generation from Doxygen. And one of the jobs here uploads from GCC, Linux using GCC, uploads the artifacts for coverage. And then our published artifacts pulls those up, like basically downloads them back down, expands them, and then publishes those through GitHub pages. So this actually allows us to fill up our docs stuff, or basically fill up our GitHub pages with a whole variety of different things. The main location for where all that stuff goes is into the docs folder. So if you want to add your own header, like landing page for your library or for your project, you can just add it in there. We don't disturb any of your other files unless you use one of the reserved names. The reserved names are API and coverage. As long as you don't overload or use those particular names inside your docs folder, you're pretty much scot-free. To do whatever you like in there and then have that be published automatically for you. The main reason why I simplified it down to one file is because I wanted to have this work as it does now, having that blocking nature and then also hierarchy, making it more hierarchical. And making sure that you don't accidentally deploy something before all these checks have been confirmed. That's CI. Let's go back. You also have the ability to add variables. We had the ability to do that before, but if we ever want to tweak and tune things with the CI, we have the ability to do so, which is actually less important for just in general saying, hey, we're going to add a whole bunch of features, but more important to say that if we ever make a mistake or need to upgrade something, we can have opt-in stuff for that and then have backwards compatibility if we want. So that's what the variables kind of give us. Notable updates. GitHub pages, the GH pages branch is no longer necessary. Before, with the previous setup, you would have to push that branch, and that branch is what would be picked up by GitHub pages. But now you can do everything through actions. So we actually eliminated that branch, so you don't have that extra branch kind of laying there. That's like 1,000 commits in the past. It also, the way it's designed means it's a single entry point for CI. So like rather than having 4 of them for lint, docs, and test, and making sure you keep them consistent, you just have one. You're able to enable disable coverage if you wanted. Only libarm cortex is set up for CI. All others are broken. We're currently working on fixing those up, so just keep that in mind. It doesn't break the being able to pull them down through Conan. It just means that like when we make updates, those pre-submit checks don't really do anything, or they're just all broken. That's the new CI. And again, we're I have in the back of my head to figure out how we should be doing that for projects. Um, I'm also thinking about adding in build checks as well. So if you have demos, if you're a library, there should be a demos folder or a demo folder. And we go in there and we basically build all your demos. And your demos should be buildable from, and this is where it gets tricky. I was gonna say from a single CMake project, but that's not okay because what if you want to support two different tool chains? CMake does not allow you to support more than one tool chain, and we need more than one tool chain specifically to compile things between different compilers. One for ARM, let's say the other one being for RISC-V, or even better yet, just simply one that's going to run on the host system and one's going to run on an actual device. So because of that, I'm not exactly too sure exactly how we do builds for like demos and that kind of thing. Right now, we have them separated as separate YAMLs, and everyone has to figure out their own thing. But I am looking for a way to make that consistent, or like package it all into our GitHub workflow. All right, so there was the projects demo alpha project, which I don't know why I relinked here, but because I'm talking about the non-demo ones. So when I say project demo, I'm actually let me bring this back a little bit. So libhal has a whole bunch of different projects. There's a whole bunch of project boards. And in these, we have issues from a variety of different repos all collected into these project boards. Now, Project Demo Alpha is about getting drivers of basically putting in all the drivers required to enable the robotics team at SJSU to be successful, as well as also give a good number of libraries so that A, the robotics team can extend their stuff if they need to, but also B, allow developers like ourselves to be able to build a reasonable project with libhal. So that's the whole idea of the Project Demo Alpha, which will help us to get to a beta once we start seeing all the different alpha stage projects, if they have any issues or there's anything that's like not very ergonomic. We also have on top of this too, though, docs and cleanup, easy assignments, and our technical debt. Easy assignments are just that. They are assignments that I believe to be rather easy. So like, they might just be tedious, but they're things that are pretty reasonably easy to get through. So if you're looking for a good first project, I would recommend one of the easy assignments. Docs and cleanup have to do with architecture and making sure that we have things well documented. So anything, mostly it's documentation stuff, but there might be some cleanup stuff in there as well, like the split I would have put in there if we didn't just do it without making any issues. And then our technical debt is basically things that are just technical debt. It's basically like a dumping zone for all of our technical debt. It doesn't matter which repo it comes from. It doesn't matter that the technical debt may be like those same issues may be shared within like project demo or easy assignments. Doesn't matter. Basically, it's just a big old project to hold all that stuff, and you can see it. Take a look at it from here. So we have quite a few things here, like just unit tests are a big one, just making sure we fill up unit tests. Check that dynamic memory allocation works on LPC with libhal. I have this hunch that that the linker symbols that we are using with the common linker script we're using basically gets the whole memory allocation thing set up for us by default, which means that we don't have to write it ourselves, which would be great. So if it does do that, fantastic. So things like that. There's little bits of technical debt that we should figure out. Oops, daisy. And then easy assignments. We could look at a couple of these here. Like unit test the frequency UDL, user-defined literal. That is really easy. It's really like, make sure that 1 megahertz equals 1 million in the unit that we're using. Make sure that, 1.25 hertz is 125, that kind of thing. Yeah, so a couple things in here, and they vary on what exactly their purposes are. And yeah, that's our pretty much non-demo project. So if you are curious, if you want to work on something or just curious to see what we are going to be working on at some point, you can take a look at some of these ones to see what's in store. All right, so I was working with Nate on getting some of the instructions set up for Conan, or just getting Conan set up in general. We always hit this problem where we when you try to build stuff, you get like a couple like, oh, like you're using GCC 9 and like, the thing that you're trying to use requires, GCC 11 or above to support C++ 20, this kind of thing. And after kind of running through, well, luckily, I discovered that we have code spaces. Code spaces, I can basically spin up a VM on GitHub and pull down a branch and start testing things out, which allowed me to get another view of what it looks like when you're just starting out, rather than having to spin up my own VM on my own machine. And that's why I realized that that was the issue. So I have a couple commands you can just run in order to set your compiler to the appropriate one. And this should get you past most of the issues. There's only one last issue, which is running Conan create. Conan create may still use a compiler that's not the compiler defined here, which means you have to set an environment variable in order to force it to do so. It's kind of annoying, and it's not easy to find that that's what you have to do, but it's the thing you have to do. These helper instructions help you out. So if you're on Linux or Windows, you run these set. If you're on Mac, just run these set, and you should be good. Libhal starter, it's a work in progress. Here's what it basically looks like now. We have our workflows, you have docs, you have project, you have tests, and a couple other supporting files. There's not really too much here, I don't think. Actually, let me check. What's in projects? Yeah, actually, we have a fully fledged application here. I don't remember if we went over this already last time. Let me check. Let me actually check real quick. I'm going to check to see if we went over how this is organized. I don't think so. We went over multi-target applications in libesp. Okay, no worries. All right, so let's go over this one more time. Where are we? We're here. Go to slideshow. Actually, I need to get out of here anyway. So here we have our project folder. I'm going to zoom in a little bit. We have our applications. We have our targets. Then we have a couple of linker scripts and that kind of thing, and our toolchain file that we can only have one of. You get more of the files. You can only bring in one for a CMake lists project. Our Conan file, which just includes liblpc at this time, doesn't include anything else. We hope to have support for everything else, though. A hardware map, a main, and a new lib. Now, I'm going to bring your attention over to hardware map again from last week's conversation on this. So here we have a serial for terminal, a output pin for an output pin, an input pin for an input pin, and a steady clock and a reset function. Here we're taking the starter hardware map and we're bringing it into our application. We also have an initialized target which returns back either an error or a hardware map. The idea here is, and this is something that I want to go over with the robotics team next time we have an opportunity to, I want us to take, as a first step when it comes to developing a project for libhal, I think the first step should honestly be developing the hardware map and coming up with what that should be. And the more abstract it can get, I think the better. And the reason why I say that is because it gives you a lot more flexibility. And this is not limited to just having these two functions. This is just a starter. Specifically, what I have in mind is, let's take the Mars rover that we're developing in general. Let's say that we have, if we just look at the low-level stuff, you would have a CAN bus driver, and you would have an I2C driver. Anything else? I think we also use a couple analog pins, so some analog pins. And maybe some GPIO for some LEDs here and there. Okay? Cool, we have those. And maybe for reading some buttons and stuff like that. So we have those. You bring those over and you bring them into your application, and your application, shoves the CAN stuff into the CAN router, takes the CAN router, brings that into RMD class, and so on and so forth. Well, if you notice, we kind of did couple like the RMD motor driver to our application. Now our application requires RMD motor, which is probably fine for what we're doing initially. But what would be really cool, and not just cool, but like would make our code even more modular, would be to have a setup where you abstract it even further. Rather than having our hardware map just include, or maybe even have like a not just a hardware map, but have like something else called like a I'm not sure what to call it, device map or something like that. But the main thing here is that like your hardware map includes like your target related peripheral stuff, or whatever you need to construct to make that happen. But the next side here is things like motor, servo, accelerometer, that kind of stuff. Because now what you can do is you can now abstract away that bit of information too. You can now swap between, like, if you use an RMD motor and an MPU 6050 accelerometer. If you have that in your application, if you define those and implement those in your, or you construct those in your application, now you're bound to those. But if you abstract it and use a servo and an accelerometer, a set of servos, a set of accelerometers, now you're in a spot where if you ever want to change out your MPU, you simply go into your initialized devices or something like that. I don't know. I don't have the name yet. I'm still thinking about it. If you have any ideas, tell me. We have another one of these functions here where you pass the hardware map into it. It constructs those objects, passes those back in its own structure, and you pass that into your application. And then you go, okay, well, now we're just a ambiguous or a generic rover project. We can work with whatever servo you throw at me, as long as it fits certain characteristics, and whatever motors you're looking for propulsion, and whatever accelerometers you want to use for, getting orientation or getting, balance or whatever. So that's one thing to say here. Let's see what time I have. Okay, kind of running out of time, but we don't have too much left after this. So that's the targets. I'm sorry, that's the hardware map, and that's kind of the first thing you want to think about. I was reading one of these books and on like the idea of doing portable firmware, and the guy says straight up, he's like, stop thinking about hardware when it comes to firmware. Think about data, think about transactions, think about the structure of things, and I do 100% agree with that. Think about what parts do you need at a fundamental level, and then make the object construct the right drivers to then fill in those blanks, to fill those things up until you're completely full. Then once you're completely full, run the application based off of it. Next up, we have our application stuff. I have like a blinker, a button LED, and a hello world. These all work. Blinker's pretty easy. Just PMAP, get the output pin, set it to true, wait a half a second, set it to false, and loop and loop and loop. Button LED, same thing. Just read the state of the input pin, then just output it to the output pin. Sorry, I'm yawning a little bit. In hello world, print out hello world. Do a write with terminal, put in the string hello world, and then wait 1 second each time. And that's kind of the idea. You pass in this PMAP, and then you just access all the different parts inside of it that you need, and you don't have to worry about where they come from or how they're implemented. The application logic is separated away from the hardware that it's used underneath, that it uses. And then our CMake file is a bit interesting. We have that double for loop we saw from last week, where we have our targets, and then we have all of our different demos, and we basically just double loop, build all these, and then you're pretty much good to go. There is one consideration, which is this will not work for libstm and other targets. To some degree, it should or should not work. So this technically should actually work with all targets, because all of them are either header-only libraries, or even if they weren't, when they get linked in, they'll be garbage collected if you don't actually use any of their drivers. So linking in every single possible driver that you ever want to link in is fine. That's doable. But I do think that it may make more sense to make this list the target name plus the library name, just so that it knows what to link in here at this stage. But I'm not sure if that's easily done. So I'm looking at that. But yeah, this is not completely developed in a way to make it really easy to switch between controllers yet, but we are working on it. So that is pretty much the starter. Not much here yet. It's still very rudimentary. We're still adding a lot of things for this, so we'll get there. All right, so we're almost near the end. We have libhal landing page. It's very basic. Basically, when you go to libhal github.io, it just shows you this. Has a link to GitHub, has a link to YouTube, which this video that you're watching will be uploaded to. And then click a button to go to read more. On top of that, too, from the landing page, you also have a landing README for the organization as a whole. It's actually with this repo dot, where is it? Where'd it go? .github is meant for. We have a couple of new additions when it comes to repos. But yeah, this just has like some of the basics for setting up with libhal. I'm thinking about getting rid of these library badges. I don't think they're really going to make sense, except for maybe safety critical. I think allocates doubles and throws like that. I don't know if that really matters. Supported's nice though. Oh my goodness, it's the old logo. Oh yeah, we gotta change these. Might just delete all this for now because I don't think it's super helpful. We'll have our standards and people just have to follow them. Libraries that are available, motivation for the project, as well as also a glossary to explain to you all the different parts and pieces and the names for things. But yeah, and here you can see libhal starter, the new util, and the new, well, that's it. Yeah, we have a little starter. We have a little starter README, and we also have a README or a page from here. I actually plan on putting all the like documentation about how to use libhal, not their libraries, or like, sorry, how to use the libraries, but not how to use libraries. By that I mean, I'll explain how to install the libraries and where to look for information on how to use them directly. But the information about how to use a particular library like libarm cortex or liblpc should be within its own repo and not in some centralized place. Just because I think that's just going to, centralizing all this stuff makes for complication and problems. Mostly that we all become gatekeepers to people who want to put libraries in. But for our own libraries, or just for the basic like, generic stuff, we can all put it in the libhal github.io directory. Oh, and then the .github directory is now like the de facto directory that has all of the organization-wide issues. So things like create target library libstm f4, create one for MSP, create one for Linux, which I'm really excited about if we can get that going, because it should be rather easy, honestly, out of all the targets. Well, software-wise, building software, building the actual target itself is probably one of the hardest, because you have to figure out how you're going to manage that for the most part. But no, liblinux should be pretty easy. But yeah, like those are things that you can't fit into libhal because it doesn't really make sense to put that in libhal. You could, but it's just I think it makes sense if we have something that's like global for everything, and then a couple of these things for making code and package guide and that kind of stuff. So that's that. I might just move a lot of this documentation stuff over to the other one because I think that makes a little more sense there. Yeah, that'll make more sense there. So that is the new landing page. It's just their placeholder until we have like a real one, a real nice fancy web page to start off with. Actually, I think Denise actually made a comment about how most websites are kind of jank. Like if we go to like Elcove right now, like look at their website. Like this website's old, very very old. It's not looking too pretty, but you know they don't really care. Their coverage for the most part. Oh, man, I'm trying to think of. Oh, well, we'll see in a sec. You'll see in a sec the one that I think is done a great job when it comes to this, right here. So first, I'm going to show you the new uploading bar for NXP Prog. Look at this. All right, we're printing the blinker. So I've improved the granularity of the uploading speed because before it was very choppy. And the reason why it was choppy is because we did it after every not partition sector, not sector. We basically did it after every block is written to Flash. So you don't see anything, then boom, it increments, boom, it increments, boom, it increments again. Now I'm doing it with every page of RAM that is sent over. It's a lot more gradual. And yeah, I think the experience looks a lot nicer in general. And you also have like this number here is actually an estimate. This is the elapsed time, and this is the amount of data that needs to be sent over. Yeah, I think it's sweet. But even more importantly, I got this from Pip's. From Pip, I saw Pip do like having this bar. And I was like, that bar looks nice. I want that bar. And then I started looking into it a little bit more, and that's when I found this thing. Look at this. That's all in the terminal. It's all in the terminal. Now, I've seen scrolling and stuff like that in the terminal before, but man, does it look so clean here. And those are buttons. You can press on those. Actually, those are warning messages. But look at that. Look at that left. Look at that that sidebar pop up. It animated. And this is literally still all single character terminal stuff. You have, everything has to be boxing this because it's all just, terminal. But it gets even better. Oh, look at that. Look at that. Got hovering and all that kind of stuff. It gets even better because I just want to show this off. I think it's just so neat. Yeah, we got time. Look at this. Look at this. Just beautiful. Resizing dynamically. Scroll has like some easing to it. It looks like I can see this as a normal website right now. I can see this like, being on a Chrome on a browser, like, but no, it's in a terminal. I'm gonna skip ahead a little bit because there's some other like, really nice sections here. There's this thing here, which is a browser viewer because we have emojis in command line, so you should be able to just do this, and you can like look through all your code through this. I mean, this is one step away from, if we get one additional bar on the right hand side, it'd be a preview bar somehow, which I don't know how you're gonna make that happen, and like allow you to actually edit this code. You basically have a VS Code minimalist blend that works on command line. Yeah, and then let's skip ahead a little bit more. This part here with all the different colors was beautiful, but what really blew my mind was this step over here. And the easing that you see here with all the scrolling. Look at this. Absolute madness. Easing animations in command line, in the terminal. Absolutely gorgeous. So, yeah, I just love that a lot. That just blew my mind the first time I saw it. Like, just the amount of effort and time required to make all this stuff happen. Basically made an entire GUI in there. So, that's a thing. And, yeah, I think that's pretty much it. Any last comments, questions before we stop recording? No questions? All right.